going south, going south. Going south, going south.
This is Seymour Rocks reporting from down under. I just want to do something on the Arctic, but I want to start off with this, because last week I posted a video and stuff on my blog on what I regard as being the most important story for the whole of humanity, and it was this. It was Russian scientists find most powerful ever methane seep in the ocean layer. They've discovered the most powerful methane gas fountain ever recorded, highlighting the danger of this greenhouse gas accelerating climate change or causing an oil or gas spill as it erupts from the thawing permafrost. The concentration of methane from one of these areas where the water was boiling over an area of 50 square feet was up to 16 parts per million, more than 9 times higher than the atmospheric average. So what was interesting about this was who published this information and who didn't. So I got it first from Moscow News, which is an English language publication in Moscow, and then it appeared in Newsweek, and then it appeared in the Telegraph. So a couple of days later I went onto Facebook and people were starting to post this, and I didn't pay that much attention. I went to repost it, but the date for this is 13th of December 2011, so that's 8 years ago. And of course it's pointing to this very problem. I didn't notice that they were talking about a different ship, and the various details were different, but they seem to be describing ostensibly the same phenomenon, well, not ostensibly, actually the same phenomenon. But what was interesting, what really struck me, was that this is the most important climate information that I could ever imagine, and it was totally missing from the normal suspects. In the mainstream media it was missing. Not a word from the BBC, not a word from the Guardian, and I thought, oh good, the Independent's covered it, but of course I didn't look at the date stamp. So that says a whole lot about what it was possible to say then and what it is not possible to say now. The fact that the Independent wrote a very good and informative article in 2011 about methane plumes, and their absolute silence in 2019. And I can almost tell you kind of why they're willing to talk about Greenland, you know, the ice sheets melting far earlier, but they're not willing to talk about the sea ice, because the sea ice produces rapid changes. No matter how quickly the glaciers of Greenland are melting, they still fall within the narrative of kind of let's get our greenhouse gases down, and we'll drive electric cars, we'll save the economy in Western civilization, and we'll use climate change to put through our agenda. Whereas if the Arctic is melting and you've got methane coming up, then you can't pretend any longer. Things are looking really bad. We're living in the realm of the age of consequences. So there's a big difference as to why they can talk about one and why they can't talk about another, and you'd have to do quite a lot of provide quite a lot of evidence to persuade me otherwise.
Going south, going south. Going south, going south.
The Russian sector of the Arctic covers 1/12 of the planet. Until recently, it was off limits to Western scientists. In spring of 1992, the first ever joint US-Russian airborne mission flew aboard a Russian aircraft in the eastern Arctic to study atmospheric chemistry. The Bennett Island Project, April 1992. The project was jointly organized by the U.S. National Oceanic and Atmospheric Administration, NOAA, and the Russian Academy of Sciences. Financial support was provided by several U.S. governmental agencies, and the project was coordinated by Working Group 8 of the U.S.-Russian bilateral agreement. In the winter and spring, the entire Arctic appears to be blanketed with fairly serious air pollution, the so-called Arctic haze. However, airborne measurements have only been made in the western sector until now. Of greater interest was an unexplained phenomenon that had been seen over the New Siberian islands from satellite photographs. The phenomenon appeared to be an enormous plume, sometimes hundreds of kilometers long, emanating just from Bennett Island, a small and otherwise undistinguished island in the high Arctic. For many years there had been speculation in the Western scientific literature about these plumes. The plumes were seen from satellites every couple of weeks in the winter and spring. Some scientists had hypothesized that the plumes might be caused by the release of methane from clathrate deposits under the ocean floor. If so, this would have very important implications for the greenhouse effect and global warming. To investigate the plumes at first hand and to make air pollution measurements for the first time ever from an aircraft in the Russian Arctic, we conceived this project.
In our proposal, we said we have 50% chance we think there
I'm Tony Hansen, a physicist at the Lawrence Berkeley Laboratory. I've worked with NOAA and with Russian air pollution scientists for a number of years. Russ Schnell is a senior scientist at NOAA. Together with Sasha Polisar from Moscow, we put this project together in record time. We assembled some standard air pollution measuring equipment as well as special flasks for collecting air samples for methane analysis. The equipment was shipped to Nome, Alaska, and loaded onto a small aircraft to be flown across the Bering Strait to the easternmost tip of Russia. We flew from Nome to Providenia, where we were met by the Russian plane and crew. Russ Schnell returned to Alaska, and I went on to Chersky, which was to be the base of operations for the next 3 weeks. Chersky is 200 miles north of the Arctic Circle, on the northeast coast of Russia. It was built as an air base to supply the Kolyma River region. In the summer, ocean-going ships can unload at the river port. The activities of the town's 14,000 inhabitants are centered on the airport, transporting goods and people locally as well as in and out of the region. In the past, everything had been controlled from Moscow, 8 time zones away. Moscow had also decreed that the entire area was off limits to foreigners. Following the collapse of the old Soviet Union, places like Chersky found themselves suddenly very far away and on their own. Our project represented work and earnings that the Chersky Aviation Authority was glad to have. Everyone, from the commander to the aircraft technicians, were friendly and helpful. We had contracted for 100 hours of flying time on this Antonov 26 general purpose aircraft. The plane, the pilots and the crew were assigned to us 24 hours a day, 7 days a week, ready to fly whenever we wanted to study Arctic pollution or if a plume appeared at Bennett Island. Our flight plan would take us 600 miles northeast from Chersky to Bennett Island. On the outward and return journeys, the plane would climb and descend in a sawtooth profile from sea level to 15,000 feet to study the vertical distribution of air pollutants. Our equipment arrived in Chersky in crates and boxes, but the technicians performed the complete installation, including fabricating an air inlet to pass through the aircraft door, in only 2 days. The air inlet and the equipment were installed, and we were ready to fly. We took off and headed over the frozen lowlands of the Kolyma River to our mysterious destination, Bennett Island. Each flight would last from 6 to 8 hours. The plane was very noisy, but the crew included a cook. Every flight he made fish soup, tea, coffee and snacks, and they all enjoyed the Western cigarettes that I had brought. Finally, we reached Bennett Island. It looked exactly like any other Arctic island. We flew round and round the island, but observed nothing that suggested any hint of subsurface methane eruptions. As would be my routine on every flight to Bennett Island, I collected a number of air samples in special flasks. These were later analyzed at the NOAA laboratories in Boulder, Colorado, for any traces of excess methane. The navigator kept the aircraft to our flight plan. As we climbed and descended, the instrumentation recorded data every 10 seconds onto a laptop computer. This data was analyzed later to reconstruct vertical profiles of air temperature, condensation nuclei count, and soot particle concentration. I had brought a second computer, so I could perform preliminary analyses while we were still in flight. On aircraft missions, it's important to get as much information as possible in real time, in case you need to make a decision to change the flight plan. After a 6 to 8 hour flight, exhausted and deafened, we would land back in Chersky. Chersky was a nice town to stay in, despite the smoke from the heating plants that fed hot water to all the buildings. By Russian standards, Chersky is a comfortable place to live. Food, housing, and amenities are good. In the past, this was the reward for isolation at the furthest reaches of the country. Our accommodation was like a small apartment with a kitchenette and a shower. On the days that we weren't flying, we could analyze the data, determine the exact location of the methane flask samples relative to the perimeter of Bennett Island, and my colleague Sasha Polisar could write reports for his organization back in Moscow. The most important thing for our project was that Russ Schnell could easily phone me from Alaska. He was in Anchorage, directing the AGASP program, but also watching the satellite images of Bennett Island.
Doing just fine. How was your
If
flight?
he saw a plume, he could immediately call me, and we could take off a couple of hours later.
Does cover that.
Towards the end of the project, this coordination worked out almost perfectly. Russ saw a plume, the plane was ready, and we flew. We went to the airport, loaded our supplies, and took off to try to intercept a plume. We approached Bennett Island at 20,000 feet. All we saw were high clouds, nothing at the ocean surface. We descended and entered the clouds at about 10,000 feet altitude. Finally, when we got down to the surface, we could look up to see that the plume was actually a streamer of clouds forming at 10,000 feet altitude above the island. There was nothing at all coming out of the ocean. No methane eruption. We had solved the mystery of the Bennett Island plume. The analysis of the flask samples showed absolutely no excess methane at all. Instead, the plume is a meteorological phenomenon. The airflow over the specific shape, the topography of Bennett Island, puts a ripple into the atmosphere that propagates upwards. Way high up, maybe 10,000 feet higher up, one layer of the atmosphere is on the verge of nucleation and cloud formation. The vertical wave injected into the bottom of the atmosphere by Bennett Island's shape can trigger cloud formation at this level. And as the cloud forms, it blows away downwind. Seen from a satellite, it looks like a plume. In a sense, this was a disappointment. A methane geyser coming up through the ocean would have been a spectacular finding. But perhaps more important in the long run is the fact that we were able to make this first ever Russian-American collaborative aircraft project succeed. Chersky Aviation is looking for work. The attitude of their management is much more positive and cooperative than is typical in Moscow. The technicians are able to make any modifications that you would want in order to install equipment aboard their aircraft. They also have more modern jet planes suitable for longer range work. The pilots and crews have lifetime experience of flying under all conditions in the Arctic. Living in Chersky during a research mission is not unpleasant, and you can keep in touch with your home office. A great deal of science remains to be done in the Arctic. We now know that it is possible to collaborate effectively with Russian aircraft operators to gain access to the half of the Arctic that was previously closed. Russ Schnell and I will do whatever we can to advise and assist similar projects in the future.
going south, going south. Going south, going south.
Scientists have been puzzled for years over satellite images of huge plumes that seem to be rising from the frozen Russian Arctic. Although it covers 1/12 of our planet, the Russian sector of the Arctic was off limits to Westerners until recently. It was only with the thaw in international relations that Russian and American scientists could join together for the first time in a collaborative research effort to measure Arctic air pollution and to solve the mystery of the Arctic plumes. I'm Tony Hansen, a physicist at the Lawrence Berkeley Laboratory. About 10 years ago we invented this instrument called an ethylometer that measures one particular component of air pollution. We've used it in studies in the Arctic, both in the West and also in the Russian sector. In early 1992, Dr. Russell Schnell, a senior scientist with the US National Oceanic and Atmospheric Administration, called me up and asked me if I'd be interested in participating in the Bennett Island plume study. Together with Sasha Polisar from Moscow, we put the project together in record time. For 20 years, satellite images revealed enormous airstreams, sometimes hundreds of miles long, occurring once or twice a month in the winter and spring. Scientists had hypothesized that the plumes might be caused by the release of methane gas. They thought that frozen methane, locked up beneath the ocean floor in formations called clathrates, was melting, bubbling up through the ocean and escaping into the air to form these unusual plumes. This could have important implications for global warming and the greenhouse effect. Far from Moscow, but quite close to Alaska, the source of the plumes had been pinpointed. They were emanating from a tiny frozen speck of ice and rock called Bennett Island. It is one of the new Siberian islands off Russia's northeast coast. We loaded up a plane with supplies and atmospheric measuring equipment in Nome, Alaska. We took equipment to collect air samples to be analyzed for methane. We also brought instruments to measure Arctic haze. Our base of operations was Chersky, a Russian airbase 200 miles north of the Arctic Circle and 600 miles from Bennett Island. Chersky lies on a frozen river, which thaws in summer to allow for shipping. The town is home to 14,000 people. No longer controlled and supported by Moscow, Chersky must make its own economic way. Activities revolve around the regional air center. The townspeople were helpful, friendly, and glad to work on our project. Airplane and crew cost about 1% of what they would have cost in the States. After 2 days of preparation, we were ready to fly to Bennett Island to look at a plume. Our plane was equipped with everything we needed, including a cook who fixed fish soup and coffee for us on board. Bennett Island looked like any other Arctic island. We flew round and round but observed nothing that would hint at any subsurface methane eruptions. We collected air samples to be analyzed for any traces of methane. In all, we flew 8 missions. The plane climbed and descended in a sawtooth profile from sea level to 15,000 feet to study the vertical distribution of air pollution. Luckily, there is a telephone line between Far Eastern Russia and Alaska, and we maintained close contact with our colleagues. Towards the end of the 3-week project, I got a call from Russ Schnell in Anchorage.
Добрый вечер. Хорошо. Doing just fine. How was your flight, Russ? Yeah?
A plume had just blown.
Are we getting lots
We were
of
in the
things?
plane
Yeah.
and ready to go. We approached Bennett Island at 20,000 feet. All we saw were high clouds. Nothing was coming from the ocean surface. We descended and flew right into the plume at about 10,000 feet. Finally, when we got down to the surface, we could see that nothing was coming out of the ocean. There were no methane eruptions. The plume was actually a stream of clouds forming 10,000 feet above the island. We determined that the plumes are actually a meteorological phenomenon caused by the shape of the island. The scooped-out shape of the 1,000-foot cliffs on Bennett Island perturbs the atmosphere. When the frozen layers of air full of water vapor and cloud nuclei reach a suitable altitude, maybe 10,000 feet up, a cloud may form. Seen from a satellite, it looks like a plume. Our data analysis showed no methane whatsoever. We had solved the mystery of the Arctic plumes, and more than that, we made good friends into the bargain. The prospect for future Russian-American scientific collaborations in the Arctic looks very bright indeed.
Going south, going south. Going south, going south.